And now we're on question 10, and question 10.1 says A, B, and C are three events. The probabilities of these events or any combination of them occurring is given in the Venn diagram below. So we have this Venn diagram and they've given us the probabilities of each event occurring and of course combinations of them. Now the first question 10.1.1 says if it is given that the probability that at least one of the events will occur is 0.893, calculate the value of A. You need to calculate the value of Y. That is the probability that none of the events will occur. Okay, before even diving into this question, I want to explain something quickly about Venn diagrams. Venn diagrams are one of the simplest parts of probability. When you get a Venn diagram, it's really something that you shouldn't be worried about. And I explain Venn diagrams in more detail in these two videos that I'm showing you now. So you can check out those videos if you know that you struggle with Venn diagrams. Okay, so looking at each of these numbers, first of all, I want you to notice the fact that everything is in decimals. Now, when we're speaking about the probabilities of an event occurring, right? All the events, all the possible outcomes, it is the sum of every single event that could possibly occur. Because these are in decimals, if you had to find the sum of every single event that will possibly occur and you add them up together, it's going to give you 1, which really just means one whole. So this is 0.05 out of that whole, and so on. That's how all these numbers are being represented. Okay, so that first question, A, they want us to find Y, which is the probability that none of the events will occur. So this is the one outside. Something I want you to realize, because it is outside and all of these ones are in these circles, remember that every single thing here adds up to 1. So if everything here adds up to 1 and Y is just sitting outside, so to find Y, we would just say 1 minus the sum of everything, the probability of A or B or C. Okay, now look at the scenario and see, look at the case they gave you here. So they told you that if it is given that the probability that at least one of the events will occur is this number, then you have to calculate the value of Y. At least really just means at lowest. So they're saying the probability of at lowest, the minimum amount of events that should occur is 1. So if we look at these circles, let's see which ones would be included in this. Okay, so at least one event will occur, meaning the minimum values, the minimum amount of events that must occur is really just 1. Okay, one event. So as long as it has one event or more, then we're going to take it. So look at this one. How many events does this include? Well, this is the probability of A only. So this is included. This one, how many events is included here? This is the probability of A and C. So there's 2 events. So it's included because the minimum amount of events we must have occurring is 1 event. So as long as it's 1 or more, we take it. Look at that one, C, right? C is only C. This amount here is for only C. So it means that we include that because 1 event is occurring. This one, 2 events are occurring. So the minimum amount is 1. That's also included. This will also be included. 1 event is occurring. This is included. 2 events are occurring. And the middle will definitely be included because 3 events are occurring. The minimum amount of events that we need to occur is 1. So anything that is above 1, we take. Anything that is 1 and above. So we also take that. So now we understand this as this part says at least one of the events will occur. That is the sum of all the probabilities inside all the circles. So all those probabilities, they add up to this number. So in order to find Y, again, just like I had previously here, but I removed it, where I said 1 minus the probability of A or B or C, probability of A or B or C is also the sum of every single thing here. That's why we find Y by saying 1 minus this number, because this is at least one of the events occurring. That's the sum of all your circles, everything that is in these circles. So 1 minus 0.893, that is going to give you your number. And put that on a calculator and this is what we get. We get 0.10 10, 7, but you can round off to 2 decimal places, so that will round up, and so that is 0.11, and that is the value of y. Then in B, they ask us, we need to determine the probability that all 3 events will occur. Remember, all 3 events occurring means all 3 events are occurring at the same time. So that is x, of course. They did mention that that is x. So to find x, the information they already gave us above is more than enough to find x. We already found y, that's not a problem. But to find x, since we know that this, right, at least one of the events will occur is this number. And we know that that is the sum of everything we have in the circles. Then we must just add all the numbers in the circles, including x, and make it equal to this, because we know that it sums up to that. Okay, so let's go ahead and do that. So there we go. This is the sum of everything in here. And then we just need to solve for x. So add all your numbers together. So I'm going to add all of this with all of this, and then say plus x. Or I'll really just start with x plus, and then all the numbers. And when I add up all the numbers that are underlined in blue, I get 0.733. So I'm just going to say x plus 0.733, that is equal to this number that we have, 0.893. Then to solve for x, you're just going to go ahead and take that 0.733 over, so that is 0.893 minus 0.733, and then put that onto the calculator, and that will be your answer. So x is equal to 0.16. Okay, and since I have these numbers down, I'm going to fill them into the diagram, and then just so that we have all those values. Okay, moving on to the next question. The next question, 10.1.2, says, determine the probability that at least 2 of the events will take place. So if you watch my video on Venn diagrams, you'll be able to answer this question very easily. So just break down the question. At least 2 just means that at lowest, the amount of events that should take place is 2 events. So it means that the minimum amount of events we're looking for now is 2. So we're only going to take those values that have a minimum of 2 events. So as long as it is 2 events or more, then we're going to take those. Okay, that's what at least 2 means. So we're going to go up here and let's look. So first of all, 0.05. This is the probability of A occurring only. That only includes 1 event, so we cannot include that. If you also look at C, that is the probability. This number here is the probability of only C occurring, and that is the probability of only B occurring. So we cannot take those because only 1 event is occurring in those numbers. So in these ones though, look at the intersections. How many events are occurring here? That's 2 events. So we're taking that. We're taking 2 or more. Here, that's also 2 events, A and B. And then here, that's B and C. That's 2 events. And finally, the intersection. How many events occur here? 3 intersections, A, B, and C, all occur here. So these are the numbers we're going to take. We will add these numbers up and then give them that answer as a decimal as it is. Okay, so that is 0.15 plus 0.1 plus 0.16 plus 0.2. And then we get 0.61. So that is the probability that at least 2 events will take place. Okay, so 10.1.3 says, are events B and C independent? So the rule for independent event is this. If events are independent, then you will notice that, and I'm going to use B and C here because that's what we need to really focus on. So you would find out that the probability of B multiplied by the probability of C would be equal to the probability of B and C. So this is really what we have to look for. We need to look for the probability of B, the probability of C, and the probability of B and C. Okay, so let's start off with the probability of B. So, like you would have seen in that video on Venn diagrams, the probability of B is the entire circle of B. Everything that is included here is the probability of B. This is not excluding intersections like probability of A and B, because the probability of B is included here as well. Okay, so this entire thing gives you the probability of B. So if we add up all these values, we will get the probability of B. So when I put that down onto the calculator, I get 0.643. So that is the probability of B. So the probability of B is 0.643. And we need to now multiply this by the probability of C. Now, the probability of C we would also get by taking the entire circle of C, because everything here includes the probability of C. So we'd add all these numbers up and we get the probability of C. And I get 0.56. Okay, so I've also just decided to write it on the side as well. So that is 0.56. So that's times 0.56. Then lastly, we have to find the probability of B and C. So what is the probability of B and C? Okay, so probability of B and C, looking in your Venn diagram, that is the intersection of B and C. Now look at those two circles. Where do they intersect? They intersect all through here. That is the intersection of B and C. Okay, so you have to take these two numbers and add them because they are the probability of B and C. Though this one has the probability of A in it, it's also still the intersection of B and C. So we add these two numbers, 0.16 and 0.2, and that is our probability of B and C. And we get 0.36. So that's 0.36. Okay, so let's see if this actually works out. When we take this and we multiply it, it should be equal to 0.36. So let's multiply those two. So when I get that, when I multiply it out, this is what I get. I get 0.36 basically, because even if you round it off to 2 decimals, it will still just be 0.36. Okay, and this is equal to 0.36. So that means that the probability of B multiplied by the probability of C really does give us the probability of B and C. And so therefore, it means that events B and C are independent. Okay, and that is it for 10.1.3, and that is really it for 10.1. Then we move on to the 10.2 questions. Okay, so 10.2 says, a 4-digit code is required to open a combination lock. The code must be even numbered and may not contain the digits 0 and 1. Digits may not be repeated. And the question is, how many possible 4-digit combinations are there to open the lock? Okay, so a 4-digit code. It's a code, so it's including numbers. The numbers that you're going to have on any number keypad would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. These are the type of numbers that you're going to find on a keypad. But then now we have to look at the restrictions that they're making here. First of all, they tell us that this code has 4 digits. So we keep in 4 places, 4 digits that it has. And now they also tell us that the code must be even numbered. So the codes that we're going to have, it must be even numbered. So in order to make a number to be even, you just have to make sure that the last digit is even. Okay, so if the last digit is a number that can be divided by 2, then the whole number will be even. So that whole code must be even. So it means at the end, right, we must have an even number. Okay, but let's also just see the other restrictions they put. They also said that, and the code may not contain the digits 0 and 1. Okay, so 0 and 1 must not be there, meaning I cannot use 1, I cannot use 0. So I'm down to 1, 2, 3, 4, 5, 6, 7, 8 numbers to use from. Okay, and the digits may not be repeated. So you also cannot repeat. So to understand this, just think about a scenario where you can repeat codes. So in a normal trackpad where you have like 10 numbers, if they said the numbers can be repeated and they didn't put any restrictions, then we would simply just say, okay, the number of choices for the first digit. So down here, I'm going to be putting down the choices. The number of choices for the first digit would just be 10. This is like in a situation where nothing has been restricted and you're allowed to repeat. I just want you to see this so that you can understand what's going on here. So you'd say, okay, for the first digit, I have 10 options. I can take any of these numbers. Then you basically will always multiply our choices. So a simple explanation for why we multiply the choices is a scenario where, let's say you have bread and then you have two things to put on the bread. You can either put cheese or you can put eggs. So in this case, you see you have bread and you have two things to put on the bread. So cheese or eggs. Here, you only have one category, bread. And you have to mix this with either cheese or eggs. There's two categories. To find out the amount of sandwiches that you can make, you would say 1 times 2, which is 2 sandwiches, which makes sense because you can either make bread with cheese or you can make bread with eggs. Okay, so that's the reason we multiply. Okay, so the first digit, we have 10 choices. The second digit, this is in a case that it's not repeated, would have 10 choices. Third, 10 choices. And this would also have 10, right? But now we have to take into account the restrictions that are being made here. This is not what we're going to have, unfortunately, because they put restrictions and they also said it cannot be repeated. Okay, so now let's look at a scenario where there is no repetition, no repeat. You cannot repeat here. Then for the first choice, you would have 10 choices. So remember, this is not this scenario. This is another scenario where I'm not putting any restrictions on the numbers you can or cannot use. Then for the second choice, because you cannot repeat the number that was used here, you would have 9 choices. And then for the third choice, you cannot repeat the number that was used in any of these. You would have 8 choices and then 7 choices. Okay, so this is a scenario without any restriction, but you're also just not allowed to repeat. Now let's look at the situation that we have here. We know that on this keypad, we cannot use 1, we cannot use 0. So we only have 8 numbers to use. But now they have placed a restriction on the way the code should look. They said that this code must be even numbered. For a code to be even numbered, you have to make sure the last digit is an even number. Meaning, the only types of numbers you can use at the end are even numbers, which are 2, 4, 6, and 8. Those are the only numbers that you're allowed to use on here. So now already, for the last digit, you only have 4 choices to choose from. Okay, now remember, they mentioned that they cannot be repeated. So if I was going to the first choice, just to see what is going to be put here, remember that we have 8 options to use. We have 1, 3, 4, 5, 6, 7, 8, and 9. We have 8 choices, but we know that we cannot repeat. So one number is going to be put here out of these 4 numbers. But because one number has been used here already, I have to cut this down to 7 choices. I can only have 7 choices in codes that I can use here. Okay, because one of that is being used. Then in the second place, we would only be able to use 6 numbers, only 6 choices that we have here. Okay, because of this one that is already placed down and one of these numbers that will be placed down. And then in the third place, you only have 5 choices. Okay, and then of course we'll multiply that. So start with that restriction because you know that only these types of numbers can be used here. So this is 7 times 6 times 5 times 4, and let's see what that gives us. So that is a total of 840 combinations that we can make. Okay, so that is how that question is solved. And then we move on to the last question of this paper. And now we are on the last question. And the last question says, we have to calculate the probability that you will open the lock at the first attempt if it is given that the code is greater than 5,000 and the third digit is 2. Another restriction has been made here. So we're still using the above restriction, everything here, but then now the third number has to be 2 and the code itself needs to be greater than 5,000. Okay, so first of all, let's see the pool of numbers that we're allowed to use. So here, the first number, right, since it needs to be greater than 5,000, we're going to think about it like this. The type of numbers you're allowed to put down in the first place, in the first digit, will be numbers like 5, 6, 7, 8, and 9. So that it can be greater than 5,000. The code will be greater than 5,000. So this is your first digit. And then we also have to take into account that they also said now that the third digit has to be 2. So we have a second digit, then the third digit. So digit 3 has to be 2. Okay, so that one is just set. We cannot change that. Well, and remember the last digit in the information that they gave us above, they told us that it needs to always be even, right? That the number must always be even. So we're still keeping that. Here we were allowed to use 2, 4, 6, and 8. So it means now for the fourth digit, for the last digit, we are only allowed to use, because you see the third digit has to be 2 no matter what. Meaning now we're only allowed to use 4, 6, and 8. Okay, so this is what the bigger pool looks like, but we still need to look deeply at this and just make sure that there isn't any repetition, because they also said there shouldn't be any repetition. So this is our digit 2. Okay, so I'm just going to look at this as the bigger picture. Okay, so you see the issue with this, the reason I can't just go on and say, okay, numbers that I can use here, 1, 2, 3, 4, 5 numbers. The reason I don't think we can do that is because look carefully at this. If you're allowed to use 5, 6, 7, and 8 and 9, right? But you're not allowed to repeat. If you do that, there may be a scenario where you use 6 and then you end with 6. Or a scenario where you start with 8 and then you end up with 8, which is wrong because they said no repetition must happen. So we actually need to separate this. Okay, we need to find certain combinations separately. So we can first of all start by trying to separate them according to how they would end up occurring at the same time. We don't want them to occur at the same time. So if we have to do that, how about we see the fact that the problems here is if we end up starting with 6 and ending and starting with 8. These are the two problems here. Because in these scenarios, you could have situations where you end up ending with 6 or ending with 8. So let's find, first of all, the bigger one first. Let's find the scenarios where we are allowed to start with 5, 7, and 9. How about we look at these first? Okay, so in the case that we're allowed to start with 5, 7, and 9, this would be the situation. This is the first digit that we have. You're allowed to use 5, you're allowed to use 7, and you're allowed to use 9. Then they already told us that the third digit must be 2. So that's the case there. Now, if we start with 5, 7, and 9, what should the last digit be? Okay, remember they must be even numbers. Here, as you can see, 5, 7, and 9, and 4, 6, and 8, they're not the same numbers. Okay, so in this scenario, we will not have a repetition here. So we're allowed to use the numbers 4, 6, and 8 because you see, it's not going to mix with that. You're not going to end up starting with the same number and ending with that same number here. So there's no repetition there. So here we're allowed to use this. Okay, so let's think about what the third number, the third digit should be. The third digit can basically be any out of the 8 numbers. But now we have to think about the fact that right now, these are the codes that we're looking at. In the situation that we're looking at one code, you have put down one number here out of these 3 numbers. You have put down the number 2, okay? And then you have put down one of these numbers out of the 3 numbers. Meaning, because you don't want a repetition, you're going to only have how many choices out of the 8 numbers that you used? Well, that's going to be 8 minus the amount of numbers that have already been placed down, which is 1, 2, and 3. We're looking at one situation of one code. So 3 numbers have been placed down, meaning you only have 5 choices here. So if we're looking at the choices, these are just the numbers that we can use. Here in the first place, we're allowed to use 1, 2, 3 numbers. So we have 3 choices. In the third place, we are only allowed to use 2. We only have 1 choice here. And in the last place, we have 1, 2, 3 choices of numbers we can use. So you see that in the second place, we're allowed to use 5 choices because we are taking into account that this is one code, right? We're pretending this is one code, that one of these numbers have been put down, this 2 is down, and one of these numbers have been put down. So seeing that 3 numbers have been put down, you only have 5 choices remaining to choose from. So there are 5 choices here. So again, you would multiply these numbers and you would get your answer. But then we're not done because that deals with this part, the situations where we start with 7, 5, and 9. Okay, 5, 7, and 9. That deals with that. Now, with the combinations starting with 6 or starting with 8, this is how we're going to have to look at it. So let's deal with the one starting with 6. Okay, so if you're starting with the number 6, sorry, let me just be putting the numbers, the keypad numbers in black. So starting with, so I'm saying or here, so that's one situation, or starting with 6, right, as your first digit. It means that since 6 is your first digit, it's the only one that you can use in this scenario, you have one choice here. Then in the second digit, how many numbers can we use? We can't really deal with that yet. Let's deal with the fact that we know that you must have a 2 in the third place. So you must have 2 in the third place, meaning you have only one choice here. Then in the last place, now you see this is where you really need to take note of this. If you started with 6, you cannot end with 6. Meaning in this scenario, in the last place, you're only allowed to end with 4 and 8. So how many choices of numbers do you have here? You have 2 choices. So remember, all of these are being multiplied by each other. Now in the third place, how many choices would you have? Well, it's still the same situation because you're thinking about the fact that that keypad, when they restricted it, we only have 8 choices, numbers from 2 to 9 basically, right? So out of the 8 choices, we're looking at this as a scenario of one code. One number has been placed down here, one number will be placed down here, and one number will also be placed down here out of these 2 numbers. So 3 numbers have been placed down in your code. How many numbers do you have to use here? You have 5 numbers left. Okay, there. So we have 5 choices here. So that is the scenario starting with 6. We're done with that. Now let's deal with the scenario starting with 8. So, or we could have a one starting with the number 8. Again, let's look at the third choice. You have to have a 2 in the third choice. So here, starting with 8, you have one choice for the first position. For the third position, you have one choice. But now let's look at what this last position should be. We should have even numbers like these ones here. But because we started with 8, we cannot end with 8. We have to end with either 4 or 6. So it means that we have the options 4 or 6. You have 2 options here. Likewise, again, to find that second position, we are saying we had 8 numbers. 3 numbers have been placed down. Okay, we cannot put 2 numbers at the same time. They go one after each other, one by one. So minus 3 is equal to 5. So we have 5 choices in the second position. So if we multiply all of these, we'll get our answers. So you see, if you take all of that, multiply it, you get your answer. You will add it to all of these multiplied and add it to all of these multiplied. So that would give us the total amount, not the probability yet. So let's go ahead and do that. So 3 times 5 times 1 times 3. And the first one gives us 45. So write that down. We have 45 here. And then 1 times 5 times 1 times 2, which you can see that gives you 10 because the ones really just stay 1. So that's 10. And then here we also get 10. So really, all of this, it would really just be 45 plus 10 plus 10, which would be 65. So in total, the amount of combinations you can create using these restrictions is 65. But we need to make sure we answer their question. Their question is calculate the probability that you will open the lock at the first attempt, right? So you're opening the lock the first time. What is the probability that you're going to open the lock and it's going to have these properties, okay? Where the code is greater than 5,000 and the third digit is 2. We found out that possibility that there's 65 combinations that we're going to have. But now this needs to be a probability. So you need to put it over the total amount of outcomes. So this over the total amount of outcomes. The total amount of outcomes would come from the first question really, because the first question gave us the restrictions that you were allowed to use, and it just asked how many possible 4-digit combinations are there to open the lock. So in total, these are the amount of combinations we can use to open the lock. So it's out of these total. So we're taking that out of 840. So 65 over 840, that will be the probability. So 65 over 840, and let's see what that gives us. Okay, and this is what I get. I'm not really saying you can say the probability of, but you see the restrictions they gave was a lot. So if you like, you can just say the probability is, then you say the answer. So this is what we have. It is 13 over 168, which you can leave as a fraction. You can put as a decimal. It will still be fine. I like to actually leave the answer as a fraction because I feel like it's just more put together and not rounded off. Okay, so that would be it. You can also leave it as a percentage. So that is it for this video. I hope you guys understood my explanation, and I will see you guys in the future videos.